Welcome back to the DSA with DAX series. Myself DAX Patel, and today is day 26 of our DSA series. Today we're gonna solve question number 136, single number. Okay, and this is the series where you can learn DSA from absolute beginner to the advanced level. So stay consistent and learn each and every day to master DSA. Okay, and yesterday we solved question number 349, intersection of two arrays, like where we have to find the common in two arrays and return only unique values in any order. Okay, I hope you watch yesterday's video. If not, you can check out yesterday's video, link in I button. Okay, and I hope you're doing these questions in your Leetcode account each and every day. Okay, so, uh, like, let me clear about yesterday's question. So, it basically depends upon two norms array, and similarly, we checking for it if there is common numbers greater than or multiple times after that we are taking an result array to comparisons for uniqueness and so on. So it's the basic level of where you can understand what is happening. Okay, so in that questions you are like thinking about multiple things at the same time, where you can finding the intersection like same numbers in both array. After that also you can checking that these numbers don't repeat in our given array. So that kind of question with multiple things and terms you want to check at same time, that will increase your logical thinking. Okay, so today's question is similar type to similar kind of to yesterday, so we'll check that, and after that we can discuss its approach. And okay, so you have to think about it. Okay, so let's start with the question explanation. So given a non-empty array of integers nums, okay, you are given an integer array of nums which is non-empty. In each and every condition in this array has some values given. Every element appears twice except one. Each and every element appears twice except one. In that array, only one element is there which only come up with one time. Okay, find that single one. Okay, you have to find that element which come only one time. You must implement a solution with a linear runtime complexity. Okay, runtime complexity, and use only constant extra species. You don't have to take any extra new entire array or object. You can take two, three variables, not more than that. Okay, that's called constant extra species. Linear runtime complexity means your uh, runtime is should be linear. Okay, not exponential like n square n cube, not kind of that. You can use n or n log n, like log n, it's enough. Okay, so I'll explain example one. Okay, example one, input num 2 to 1. Okay, in the value of array nums, that is value 2 to 1. You can see that 1 is the element which come up with only one time. You can directly return 1 like that. Here you can see that 4 1 2 1 2. So 4 is come up with 1. So like that you have to check this condition. Okay, and you can last example also see, we can see conditions. Nums dot length is between 1 to 3 into 10 to the power 4, and nums of I value is minus 3 into 10 to the power 4 to plus 3 into 10 to the power 4. This is a very wider range, and nums dot length is also very high. So you can like writing time you have to careful for that. Each element in the array appears twice except for once, which appears only once. This is our question. Okay, so I hope you got clear about the question. So now we move to the approaches part. I'll explain all possible approaches. After that we move to the. Okay, so for this question, possible approaches are that, like, firstly we can take one for loop. Okay, and we can check comparison, like our where like taking an array of like count. Okay, it's take extra spaces, but like first approach for that is to take an entire new object and check for that. If the particular number has undefined, you can store number and increase it count with one. After that, we can do that for multiple, and at the end we can find that which element is count is one, and we can return that part. Okay, so I know this approach you might feel like it's not good or okay, but this is first approach. Second approach we can do that. We have a bitwise operator. Okay, bitwise operator is basically used to convert to the bits, okay, 0 and 1, okay. So for that we can take that part and check in comparison and use that, okay. I'll write while writing code, you can understand how this works, and I'll explain each and everything, okay. All operators are required to know. I'll explain each and everything. So start with the first approach with taking a new object, okay. So I'm taking a new object, const count equal to object for let, okay, I is equal to 0, I is less than nums dot length, I plus plus const num equal to nums of I if count of num equal to undefined, okay, undefined count of num equal to 1, okay. So this part is completed. Now we want just one else condition, else count of num plus plus, okay. So this part is completed. Now we just want one checking condition for let we using key, okay, key in count, okay, if count key, okay, equal to 1. Key means basically nums value, which nums value is equal to 1, return number of that key, okay. I hope you got clear about this approach also. So this part is completed, okay. Now we'll run this for, okay, you can see that these test cases are accepted, our runtime is 0 ms. Now I'll submit this for further lead code test cases should be checking. So you can see that this is also accepted. Now I'll explain what is we are doing in this part. So this part we already know what is happening. We're checking that the current nums value should be exist in our count object. Not existing, we can creating it, okay. And in else condition, if exist, we can directly just increase plus plus, so increasing value by 1, okay. Now here in this for loop, with checking is like our key is basically value of nums, okay. In our count, if key is value equal to 1, we taking the number value of that key, okay. Each and every value of object has a key. We taking that key to check for our one value, and we using that key to find the number and returning the number, okay. So I hope we're clear about this approach. So now we move to the second approach, which is bitwise operator. So before that, I'll explain you some things which is required to learn, like AND operator, OR operator, NOT operator. Okay, which we'll use. I'll explain, but I'll explain each and everything in this approach, so you clear about that. Okay, so we start with the AND operators. Okay, I'll write and each and everything explain. So basically, AND operator we are writing like that, and then it used to like if the given condition is true, first condition, and other condition is also true, okay. If both condition is true, it will return you like true, okay. And here we use and wait, I will fix this, okay. If our both condition is true, it will becomes true. That's called AND operator. While using double AND, it's called AND operator. Another operator is one condition is true, okay, and other condition is false, okay. but our answer is true. Okay, so this is OR operator which is used to like either of any of these two has to true. Our final condition is valid and it becomes true. That's called our OR operator. Okay, so one more there is like not operator. We using it many times. Okay, you know it's basically means that not. Okay, not means like no true. Okay, no true becomes false. It's basically used to reverse things. Okay, if you like use like if you given a condition which value giving you true either or false. Okay, so if true comes it will convert it to false, if false comes it convert to true. Okay, these conditions will check for if both is true, answer is true, if both is false, answer is false, one true one false it becomes false. Okay, but in this condition if both is true it will also true, if one is true that also true. In only case where both is false, the answer will be false. Other than that, in second condition, each and everything will be true. And in this last, our not operator, each and everything is be reversed. Okay. Now our last is bitwise operator. We can write that according to using this. Okay. So it's basically what it's doing is five. Okay. Five is bitwise operator. See. Okay. So five's binary code is 101. Okay, you know that how we can converting it to binary. 5 binary is 101 and 3 binary is 011. Okay, so 10 you can see here like that. Okay, this is 501. Okay, I writing like that so you can clear about more that. Okay, now I writing this to 01 becomes 1, 01 becomes 1 for that also, and 1 becomes 0. Now 1 like it's basically first we have whatever first is 1 2 4. So 4 and 2 it becomes 6. So 5 bitwise it becomes 6. Okay, so this is our answer. This is called, we can call this operator. Okay, so last one bitwise operator we're gonna use, and due to its one special conditions, if we you do that, okay, it becomes 0. X bitwise operator, X becomes 0. Okay, okay, I hope you got clear about that approach. So now we move to the code part. For that we just taking that let result equal to 0. Okay, and for result I, my mistake, let I is equal to 0, I is less than nums dot length. Okay, I plus plus result. Okay, bitwise operator with equal to nums of I. Okay, and at the end we returning it. Okay, so at the end we return result value. Okay, so I hope you clear about this approach. I will like run test cases. Okay, so we can know that our approach is true or not. So this is accepted, or like we submit for Leetcode test cases. Our given three examples cases are accepted. Okay, all 61 test cases are accepted. So this is our questions where we done this by bitwise operator. Okay, and I hope you got clear about these new things. Okay, so now I'll explain you the time and space complexity for our both approaches. Okay, for first approach, our time complexity is order of n. You know that why is order of n. We're taking one loop from the starting of the our nums array to the ending of the nums array, it will becomes order of n. Okay, and space complexity for that approach we're taking in is same as the current nums array, like as new object, same as the nums length. So space complexity becomes order of n. Okay, but the questions want you can use only constant extra spaces and write the solution for that. So we doing this by in this approach. Okay, here we just taking one element, result element, not entire array or object. So space complexity becomes order of 1 for this approach, and time complexity is order of n for this. Okay, so this is the time and space complexity for our both approaches. Okay, and now you can I like first approach we used, like common thing, checking in our object, is this number array index is undefined. Undefined, we are creating new index, assigning it one count, and if this index is exist, we can increase it to count plus plus. Okay, and at the end we can taking key value of the each and every nums count. Okay, like 5 comes 3 times, like 5 comes 4 times, 2 comes 2 times, 1 comes 1 time. So we'll just taking that, find which number comes 1 time, we can directly return that number. Okay, so we can do this in approach 1. In approach 2 we just taking and result array, like sorry, result value variable, and we checking that and to this num result bitwise equal to nums. Okay, whenever you can do that 2. Okay, I'll explain you that 2 bitwise operator 2 becomes 0. Okay, so like that in our array whenever 2 comes. Okay, 2 bitwise operator 2 becomes 0 1. Okay, and 0, like afterward only 1 remains, so result will be store value of 1, and return result becomes 1. Okay, so this is the today's our two approaches, and if you find any doubts about today's question, you can ask me in comments. Okay, now we move to the tomorrow's questions, basic details. Okay, so now I'll show you the tomorrow's question. It's basically 268. It's a missing number. Okay, this one. This is simple question. Okay, you can try by yourself. Given an array of nums containing n distinct number in the range of 0 to n, return the only number in the range that is missing from the array. Okay, if the array is given 0, 1, 3, the missing number is 2. Okay, and if the array should be given is 0 2, like that you can check out. We directly move to the example 1. Okay, example 1 here, input nums 3 0 1, output is 2 because there is 0 1 2 is missing, and after that 3 is coming. Since the n is equal to 3, length of the nums is 3, so 3 is there, 0 and 1 is there, just missing is 2. Here you can see that length is 2, but there is 0 and 1 number is present, 2 not present, so it becomes n equal to 2 and output should be 2. Okay, for here we can see that 0 1 2 3 4 5 6 7 is there, 8 is not there, so we can write it 8. Okay, so this is the question. Okay, here are some condition. All the numbers of the nums area are unique. Each and every nums like values are unique. Nums of I is between 0 to n. Okay, n is between 1 to 10 to the power 4, and now n nums dot length is equal to n. Okay, n is basically length of our given array. And follow up. Okay, they given us one challenge. Could you implement a solution using only 0 order of 1 extra space complexity and order of n runtime complexity? So basically they already tell us, could you do that question without taking any new entire array or object by taking 1 to 2 variables and solve this question. Okay, and you can only use one for loop, not multiple. Okay, so you can try this question. After completing this question, just post it on LinkedIn and Twitter and mention me. Okay, so I hope you got clear about today's question and tomorrow's like question basic details and each and everything. If you find anything If you want code, just check out our GitHub repo where each and everything is uploaded. You can check that explanation and code in C, C++, and JavaScript. Okay, and if you're not started yet DSA with the series, link in I button. You can start with day one where I'll explain it each and everything about the series and how you can start and like do each and everything is explained in that video. I hope. Okay, so now thanks for watching the video. Meet on tomorrow's video.